Welcome back to Mechanics and Materials. Today we're going to look at some stress transformation problems and make some more circles out of them. This is chapter 9 in the book. Okay, we're going to look at problem 9-11, and this is the problem that they've given us. It's a little element like this with 150 MPa in X, 100 in Y, 75 in shear, and they're all positive, tension, tension, and up to the right. And they've asked us to rotate the stresses 60 degrees clockwise. 60 degrees clockwise is actually a negative 60 degrees. All right? So we're going to do that. And I want to use quickly the equations in the book. So the equations, of course, are given to you back here on page 451. They're also in the front of the book, and what we have to remember is, so they're also up here. I don't know if you can see, yeah, you can see that over here. They give you in the front, they give you X and tau. They don't give you Y, but Y, we just have to change some of the signs to get sigma Y. These two pluses become minuses, as shown down here. Okay, so instead of the average plus, you have the average minus. And then we'll look at principles, and then we'll draw more circle. All right, let's go. So one of the things is, remember I showed you the Excel spreadsheet, and we can actually just put these numbers in here to check our work. So we'll do 150, 100, and I know you can't see this. I haven't figured out quite how to do that yet, but we'll see what comes out. All right, and we're going to come up with eventually a sigma x prime. So here's sort of the answer, 47.5. Sigma y prime is 202.5, and tau xy prime is negative 15.85. Okay? And I just want to show you that in the back of the book, we also have the answers, and there they are, the same answers. So we're on the right track. But let's see how we did that mathematically, as opposed to just letting Excel do all the work for us. But now we know that the spreadsheet works. Okay, so we'll do one of these. Sigma x is equal to prime, of course. That's sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 times the cosine of 2 theta. So that's going to be times 2 theta is negative 120, right? And plus tau xy 75, times the cosine of minus 120. Oh, I started filling in numbers. Well, there you go. So let's write it the numbers this time. It's 150 plus 100 over 2 plus 150 minus 100 over 2 times the cosine of minus 120. So 120 change sign cosine is negative 0.5. All right, so that goes to negative 0.5 plus 75 times, oh, that should be the sine. That makes better sense. 120 change sign sine is minus 0.866. Okay? So let's do this. We'll say 150 plus 100 is 250. 2 divide. 150 minus 100 is 50, so that's 25. And then we have, oops, sorry. So this goes to 125. This becomes 50 times minus 0.5, so that becomes 50 times minus 0.5 is minus 25. And 75 times 0.866 is 64.95. Oh, no, that's right. What did I do wrong? I got the wrong answer. This is 12.5. I forgot to divide by 2. So that gives me 47.55, which is correct. Okay. And then tau xy prime is equal to negative sigma x minus sigma y over 2 sine of 2 theta plus tau xy cosine of 2 theta, which is equal to minus 150 minus 100 over 2 times the sine is 2 theta, 120, change sign, and our sign is negative 0.8566, right? Plus tau xy, which is 75, and the cosine of 2 theta is negative 0.5. So now we get 150, 100, minus 2 divide, change sign, 0.866 times, and then we have 75.5 times minus, and you get minus 15.85. Okay? And you say, okay, that's nice, but what else do we do? So what else do we do with that? Well, we are going to calculate the principal stresses and where that occurs. And of course, the principal stress equations, once again, are here in the book, right? Right here is the angle that they occur at, and the equation for the principal stresses themselves is right here. And that's also shown at the front of the book. Okay, so let's do that. Oh, and then we'll explain kind of what that means. So in the first case, we took this element and we rotated it negative 60 degrees. Where's my triangle? There it is. So we're going to take this thing, we're going to rotate this, right, negative 60 degrees, which is about like that. So now we've taken our element. Here, let me draw it straight. Right? We've rotated it like that. So now we're looking at the stresses in this orientation. In this orientation, we still have tension, but now we have negative shear. when we rotate it. But where are the principles and what does that mean for our structure? So we can calculate sigma 1 is equal to sigma x plus sigma y. Well, actually, this is 1, 2, right? Over 2, that's the average, plus minus the square root of sigma x minus sigma y over 2 quantity squared plus tau xy squared. Square root of that whole thing. And this, remember, we said was the radius. So the average, sigma average, is just going to be equal to 150 plus 100 over 2, which is equal to 250 over 2 is 125, right? These are all MPAs. All MPAs. And the radius in here is going to be 100 minus 150 minus 100 over 2 squared plus 75 squared, and then we take the square root of that. So 150, 100 minus 50 to divide. We square that. Then we take 75, we square it, we add those together, and we take the square root. And you get 79.06. $79.1. Excuse me. All right, so now we know that sigma 1 is the maximum, and that's going to be equal to 125 plus 79. And that's 204. And sigma 2, which is the min, is equal to 125 minus 79. 125, enter 79, minus is 46. And theta, well, we know that the tangent of 2 theta is equal to tau xy times 2, right, over the quantity sigma x minus sigma y. So that's equal to 2 times 75 divided by 150 minus 100, and that's equal to, that's 150 over 50, right? Which is 3. Yep. And we take, that's 3. So then theta is the arctangent to theta, is equal to the arctangent of that. And that's 71.6. And if I divide that by 2, that's, so theta is equal to 35.8 degrees. Okay? Now note that that's positive 38 degrees. So we started off with our block, and we had tension, tension, and shear, remember? But now we're going to rotate that, let's see, roughly like that, right? So we're going to take it like this. And that's where our principal, so this angle here is 35.8 degrees. Okay. That's where the principal stresses occur. So that gives me a maximum stress in the x direction of 204, excuse me, and in the y direction of 46. And there's no shear, right? No shear. So like I mentioned before, well, what do we do? These are actually useful, right? These are useful. You can now go in and you can say, well, this is MPa, of course. If this is, say, made out of steel, we know that the yield stress of A36 steel, right, is about 250. Is that right? Here's our little table of materials. Here they are. Got to use the average SI units. A36. Yep, 250. So, sorry, let me show you. There, you can barely see that. Okay. So that's the yield strength of structural steel, the A36 steel. It's a fairly mild structural steel, but it's a good one, used a lot. So if we said that our sigma tension allowable was 250, we could see that we're below 250, so we haven't yielded the material. These are MPAs, of course. If we wanted to calculate our factor of safety, that's going to be equal to 250 divided by 204, the allowable over the actual. And so that gives us a factor of safety greater than 1, which is what we want, of 1.2. So we have a roughly 22, it's 1.22 in fact, 1.22. So that says we have a 22% margin of safety. So not bad. So that's how you would actually use that in practice. Okay, you say, oh, my principal stress is low enough, not going to fail the part, let's move on. Now we've also talked about Moore's circle, and I definitely want to do a Moore's circle for you. Because we have to. All right. So let's look at our Moore's circle rules. And here's our Moore's circle rules. Right here. Remember this little picture? 9-16. So we're going to take our circle. We're going to plot it on this stress and shear. Now remember, shear is down. And in our case, we've got all the numbers we need to plot the whole thing. So let's draw a little graph here. And we know it's going to stay positive. So we'll put this over here somewhere, like this. And we know that sigma max, tau max, we know that sigma max is going to be 204. We already know that. And tau max is 80. So on our graph, we're going to stay up. Okay, let's see. If we make this 2, 4, 6, 8, because I got to go this way yet, so that's 20, 40, 60, 80, 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. Okay? So that's roughly what our circle is going to look like. Now, first we want to plot the center. Now remember, the center is the average. Remember that? We said the center was equal to the average. So we plot the average as 125. Okay. 2, 4, 6, 8, 10. That's 150, so that's roughly 125, right? And we know that the radius is 80. So we would come down here to 80. And we could put a point there, because that's our max radius. So we can go up 80 too. 2, 4, 6, 8, 10. That's negative 8, because this is tau, and this is sigma, right? And we can also plot our original points. Our original points Our original point was 150 and 75. So I would come down 75 and I come over 150. Well, this is 150 is about, let's see. Here's 75. No, 75 is like right in here. 2, 4, 6, 8, 10. Oh, I didn't put that in the right place, did I? It's all right. This is supposed to be 125, right? 20, 40, 60, 80, 100. This is 120. So 120, this is 140, so 120 is here. So this point's out here. This point's over here. And x is 150, 2, 4, 6, 8, 10, 20, 40. So here's 150. 75 is down here somewhere. And so that is our first point. Yep, this is our first point. And should use the pencil, I guess. And then the other one is 100 and negative 75. So it's up here. Oh, look, that actually worked. So now we can see what our circle is going to look like. Yeah. And then I'd have to find my compass. I have one. Hold on a second. I'm going to go find my compass. Okay, I found it. Found a lot of old stuff. Found my slide rule. All right, so we gotta make this like this. Ever seen one of these? Maybe, right? So there's our Mohr circle. Looks like I was off a little bit. Well, these things happen. Anyway, I guess this ought to be down here. But you get the idea. So that's what it's supposed to be. And we said that 2 theta was 75 degrees, right? 71.6 degrees. And that looks like about what that is. So this is, remember for our picture, here's theta, right? Here's theta. And so it's telling us that we have to rotate to get our angle, our principal stresses. All right, so we have to rotate. Our principal stress is at 204. This is 204, so we have to rotate up here. So this is 2 theta, and that looks like about 71 degrees, doesn't it? Okay. So that's how you do Mohr circle. All right. We will do more another time and do a couple more problems. Let's kind of review what we did there, though. Right? We can either use the equations or our Excel spreadsheet to generate the new stresses. And once that was just to rotate it through that angle. We can also use, again, either our Excel spreadsheet or the equations to generate the principal stresses. And the principal stresses, as I just said, are actually very useful. And we can find that center. Part of finding the principal stresses is finding the center and finding the radius. and we can plot the points on a graph. We can use a graphical method to find our stresses. Because if we had just come in, if I had done it better, and just plotted this point, right, which is sigma y negative tau xy, so that's that point, and this point is the original sigma x tau xy. Once I had those 2 points, then I would get the center and I would know the angle graphically. Okay, you know what, we got a couple minutes. Let's just do another quick little problem. See if I can do a better job at plotting this thing. Let's look at problem 9-12. No, same problem. Let's not do that one. A different question. Let's look at 9-17. How about that? 9-17. We're just going to do a quick Mohr circle example. So here's 9-17 right here. So sigma x is 125, sigma y is negative 75, and tau xy is negative 50. So let's write those down. Sigma x is 125, sigma y is negative 75, and tau xy is negative 50. And we're going to draw a quick Mohr circle. Hopefully I can do a better job of it this time, all right? So we'll make this, and we'll do this. Tell you what, I'm going to use pencil this time just in case. And 10, 20, we'll use tens this time, all right? So we said this is sigma, this is tau xy. So we're going to go 125, negative 75 for our first point. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 120, 125. And we're going to go up 75. 10, 20, 30, 40, 50, 60, 75. Now why did I go up? Because, oh, it's 50. Aren't you glad I used pencil? Because tau xy is negative. That's why. So this is negative up here. So 10, 20, 30, 40, 50, right there. And then we can plot sigma y, negative tau xy. So it's going to be over here in this quadrant. So we would go over negative 75, 10, 20, 30, 40, 50, 60, 75. We're going to go now negative 50. 10, 20, 30, 40, 50 down here. So all I have to do is connect those 2 points. And I now have my circle, right? Here's my center right here. And I can take my little compass, maybe, put it right there. Now remember, this was really a benefit before computers. Before it was easy to do this other stuff, so you didn't have to do all this math. Look at that, we even hit the circle this time. Right? There it is. So there's our circle. So we didn't need to do any math. We just had to plot these 2 points. So the center, I read the center as 25. Well, let's see what the center comes out to. So the center is going to be sigma x plus sigma y over 2, right? So that's equal to 125 minus 75, which is 50, over 2 is 25. Guess what? 25, it worked. Very exciting. And I didn't need to do the math. Well, let's see what the prime is. Well, if I'm going to use I'm not going to run the math. I'm going to put it into my Excel spreadsheet, right? I'm going to say 125. I know you can't see it, but this is what I'm doing. minus 75 minus 50. And I'm showing that sigma 1 is 137. So let's see. This is 120. This is 120. 130. It's almost 140. So maybe 138 is what I would read off the graph. Hey, that's not too bad, huh? And then let's do sigma 2. Sigma 2 is going to be, this is 75, remember, so this is 80. What do you think, 87-ish? Well, the answer is 86.8. So I got my center, I got my principal stresses. All I did was plot points and draw a circle. Okay, maximum shear stress, it's going to be down here, right? Down here somewhere. It looks like maybe 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, maybe 112? What do you think, 112? The answer is 111.8. This is why Mohr circle is powerful. All right, you don't need all that other stuff. You plot 2 points, draw a circle, you get everything you need. Personally, Excel's easier, but back in the day, before Excel, this was the way to go, right? And of course, it helps to have a handy compass. Okay, that's enough for now. We'll do more another time, but there you go. And you can review that at your leisure. Thanks, guys.